Welcome to Ask and Learn.
We are given a recurrence relation and initial conditions, and we are asked to find all solutions of this relation with these conditions. The relation is an equals 7an minus 1 minus 16an minus 2 plus 12an minus 3 plus n times 4 to the n, and the initial conditions are a0 equals negative 2, a1 equals 0, and a2 equals 5. This is a linear non-homogeneous recurrence relation. The associated linear homogeneous recurrence relation is an equals 7an minus 1 minus 16an minus 2 plus 12an minus 3. And so the characteristic equation is r to the fourth minus 7r cubed plus 16r, this should be r to the third minus 7r squared plus 16r minus 12 equals 0. And we have that the roots of this characteristic equation there are a few different ways to find out. If we plug in r equals 2, we get 8 minus 28, so negative 20, plus 32 is 12, minus 12 is 0. So we have that 2 is a root, and using synthetic division, we obtain r minus 2 times r squared minus 5r plus 6 equals 0. And this can be further factored as r minus 2 squared times r minus 3 equals 0. And so we have that characteristic roots are 2 with a multiplicity of 2 and 3. And therefore, we have that the general solution to the linear homogeneous recurrence relation is a1 times 2 to the n plus a2 times n times 2 to the n plus a3 times 3 to the n. And we have f of n is n to the fourth times 4 to the n, or just n times 4 to the n. And we have that n is a polynomial of degree 1, and 4 is not a characteristic root. So it follows that the general form for a particular solution is going to be p1n plus p0 times 4 to the n. And to find the values of the coefficients, plug the particular solution back into the non-homogeneous equation. So on the left-hand side, we have p1n plus p0 times 4 to the n. On the right-hand side, we have 7an minus 1, which is 7 times p1 times n minus 1 plus p0 times 4 to the n minus 1 minus 16 an minus 2, which is minus 16 times p1 times n minus 2 plus p0 times 4 to the n minus 2 and plus 12 an minus 3. This is plus 12 times p1 times n minus 3 plus p0 times 4 to the n minus 3. And lastly, plus n times 4 to the n. Dividing both sides by 4 to the n minus 3, we get 4 cubed, which is 64 times p1n plus 64 p0 is equal to, here we have 7 times 4 is 28 p1n minus 28 p1 plus 28 p0 minus, this is actually a mistake, this should be divided by 4 to the n minus 3, that leaves 4 squared, which is 16. So it's actually 7 times 16. So that's 4 times 28, which is 80 plus 32, which is 112. So we have 112 p1n minus 112 p1 plus 112 p0. And then we have minus 16 times, this is just 4, which is minus 64 p1n. And this is an n minus 2, so this is going to be plus 2 times 64, which is 128 p1 and minus another 64 p0 plus, and here this is simply 12 p1n minus 3 times 12 is 36 p1 and plus 12 p0 plus, and 4 to the n over 4 to the n minus 3 is 4 cubed. This is going to be 64 times n. And so on the left side we have 0, and on the right side we have 112 minus 64 times 2. So it's going to be 112 minus 64 minus 64, that's 120, 128. So that's a negative, So instead, if I move all the terms to the left-hand side, we have 64 plus 64 is 128, and then subtract from that 124, we get 4 p1 times n, but we also have minus 64 times n. And then for the constant term, for moving everything to the left, we have plus, this is going to be first with the p1 terms, we have 112 minus 128, which is negative 128 is negative 16 p1, and then add to that 36 is plus 20 P1. And then for P0, we have 64 P0. And we add to that another 64 P0 to get 128 P0. And then subtract from that 124 P0. So we have plus 4 P0. And so it follows the coefficients of this polynomial are 0. So we have that P1 is equal to 64 over 4, which is 16. And we have that P0 is equal to negative 20 over 4, which is negative 5. P1, so this is negative 5 times 16, which is negative 50 minus 30, which is negative 80. And so we have that the particular solution is 16n minus 80 times 4 to the n. And so it follows that the general form for a solution to the non-homogeneous equation is going to be the general form for the solution to the homogeneous equation plus the particular solution. And this gives us alpha 1 times 2 to the n plus alpha 2 times n times 2 to the n plus alpha 3 times 3 to the n. And then add to that the particular solution, which is 16n minus 80 times 4 to the n. And now, using our initial conditions, we can find the values of alpha 1, alpha 2, and alpha 3. So we have that a0 is negative 2. This tells us that negative 2 is equal to alpha 1 plus alpha 2 times 0, which is 0, plus alpha 3 plus, and then 16 times 0 is 0, so this is negative 80 times 4 to the 0 is just 1. We also have the equations a1 is equal to 0, so we have that 0 is equal to 2a1 plus 2a2 plus 3a3, and then 16 times 1 minus 80 is going to be negative 64 times 4 to the first, which is just 4. And lastly, we have that a2 is equal to 5, so that 5 is equal to 4 alpha 1 plus 2 times 2 squared, which is 8 alpha 2, plus 3 squared, which is 9 alpha 3, and then plus 16 times 2 is 32, minus 80, that's minus 48, times 4 squared. And so you can solve this by hand or use a computer algebra system. So I'm going to pause here. And after solving, you'll obtain that alpha 1 is equal to 17, alpha 2 is equal to 39 over 2, and alpha 3 is equal to 61. therefore it follows that the only solution to this recurrence relation with these initial conditions is 17 times 2 to the n plus 39 times 2 to the n minus 1 times n plus 61 times 3 to the n, and then add to that the particular solution which we have is plus 16n minus 80 times 4 to the n. And this is our answer.